Hi, this is Mrs. Vrobel. This is Chapter 14, Mixtures and Solutions, Part 4. So in this video, we're going to correctly describe and identify colligative properties of solutions. And then lastly, we're going to precisely determine the boiling point elevation or the freezing point depression of a solution. Okay, what is a colligative property? So it's a physical property. It's not a chemical property, and it's affected by the number of particles of a solution, not the identity of the dissolved solute. So what does this mean? If I have a solution that's either sugar or water, if they have the same number of particles, they will exhibit the same colligative property. Okay, so what happens when you add a non-volatile solute? So this is something that does not become a gas. It actually lowers the vapor pressure of a solution. So what happens is the solute that is in the solution, it occupies surface area, and as a result, there are fewer solvent molecules that actually become part of the vapor state. Here is an example where we have on the left, we have water molecules, and there is no solute present in this, and as a result, these vapor molecules readily form. However, on the right, the moment you add a solute, and it's a solute that doesn't necessarily become a gas, you have fewer vapor molecules that are present over the solution. Okay, another colligative property is what we call boiling point elevation. So you may have asked yourself, how come we add salt to water when we're boiling for pasta? And some people think, well, it just makes it boil faster. No, what's happening is the temperature is actually reaching a higher level, and as a result, your pasta is probably cooking more thoroughly. Okay, so please note that because the boiling point is being raised, you need to add more energy in order to get the vapor pressure of the liquid to equal atmospheric pressure, which is boiling. Okay, so with a boiling point elevation, we can do calculations. Now, I'm not going to do a calculation with boiling point elevation. I'm actually going to do it with another one. But this is the formula that you will use with boiling point. Now, the tricky part here is this M. This M is called molal. It's not molarity. The difference between molarity and molal is molal, we're looking at kilograms of solution, or yes, kilograms of solution, whereas molarity, we're looking at liters of solution. The other thing is there is a KB. This has to be given to you. It's a constant, okay? And when you see delta TB, you're actually adding whatever this delta TB is to the boiling point. So please note that that delta TB is not your final answer. It just tells you how much you're going to add to the boiling point. Okay, so here are some molal boiling point constants. So that means if you add salt to water, you will get a boiling point higher than 100 degrees C. The same with these following solvents. Okay, so freezing point depression. We're going to do a problem like this in a minute. And notice it's a very similar formula. The only difference is you get a Kf, which is a freezing point constant, and once again you're using molality. Please note that with freezing point it's a depression, so the temperature is actually being lowered for the freezing of that solvent. Why does that happen? Well, the interesting thing is there actually is a dynamic process between molecules that are becoming liquid and liquid molecules that are freezing to become solid. What happens is the moment you add a solute, that process is being disrupted. So you have fewer molecules that are traveling from the ice crystal state than going to the water molecule state. Okay, another thing that we can look at too is the phase diagram. So this is actually from the last chapter. What happens is You get boiling point elevation or you get freezing point depression based on the amount of solute that is in that solvent. Okay, so once again I said that freezing point depression, you're going to subtract it from the original freezing point, and it should be lower than the original freezing point. Here are some freezing point constants. So like I said, this would be something that would be supplied to you in order to do these type of problems. Okay, so the question is, what is the freezing point of 8.07 molal? And I'm going to use the following equation here. So I have a delta TF, not TB, because I'm looking at freezing point. And they tell me that I have a constant of 1.86, and that's Celsius per molal, times the molal, which is 8.07. So when I multiply those two numbers together, I get 15.01 Celsius. And the freezing point, I'm just going to do TF, equals a negative 143.7. And I'm adding a negative number, which is 15.01. And when I add those two negative numbers together, I get a negative 158.7. So please note it is lower than the original freezing point. And here's a second problem that I want you to try on your own, and we will go over that in class. Okay, so in summary, colligative properties, which are vapor pressure lowering, boiling point elevation, and freezing point depression, they depend on the number of solute particles, not the type of solute particles, okay? And the two problems that you will be doing for this part of the chapter are boiling point elevation. Please note that delta TB you're going to add to the original boiling point. And then with freezing point, delta TF, you're going to subtract, so that number should be even lower.